Kelly Hoey. I'm one of the three co-founders of Women Innovate Mobile, a New York City-based startup accelerator. And it's an absolute pleasure to be here tonight with these three, I want to say, big minds to talk about data. They love data. I love talking to them about data and the power of data to foster innovation. So we are going to discuss that most overused buzzword tonight. So let's jump into it. So sitting right next to me, Marianne Bellotti, who is, I'm going to go through all of this. You started as a prototype engineer and developer evangelist. In your spare time, she's co-founder and CTO of a startup called Exversion, but in your spare time you help organize and mentor at Hack Hours. You're a veteran of the hackathon scene. Hacking data is your most favorite thing to do, but as the co-founder of Exversion, you probably have the greatest corporate tagline, which is, "We make data sexy." How did that come about?
It was actually as a result of a comment that Robert Scoble made when we were at Startup Bus, which is where the company started, and we did our pitch, and he said, "Your idea is great, I really see the need for it, but it's never going to work because data isn't sexy." And I looked at my co-founder and we're like, what is he talking about? Of course data is sexy. So when it came time to do business cards, I was like, that is what we're putting on our business card. We make data sexy.
So what are you actually doing to make data sexy?
What we focus on...
Because I know you didn't get the URL you wanted.
Yeah, we were talking in the green room that I was very disappointed that data.xxx was taken, so that we could not have that.
There is a new .sexy TLD.
Oh my God! So we can have data.sexy.
Yes. Perfect. Go get it right now.
That is, yeah, seriously. I may have to go back and text my co-founder right now. We need data.sexy. We do data infrastructure. We're really interested in collaboration, accessibility, and also, I guess, what most people would call accountability, the provenance of data. Where does it come from? How does it change over time?
Cool. Well, we'll get into more of it. In the middle, Hilary Mason, data scientist and resident at Accel. You're scientist emeritus at Bitly. You're the co-founder of Hack NY, co-host of Data Gotham, member of New York City Resistor. You believe that, I want to say that data has superpowers and we can do things with these superpowers. But what I really want to know from having read your blog recently is, where is the most expensive average cheeseburger in the United States?
That's a good question, actually. And recently I was invited to discuss data on Science Friday, and they asked if I had any really compelling, broadly appealing examples I could share. And I thought, well, what does everyone in the world love more than food? So I borrowed some data from an API and I got a sample of burgers with their menu descriptions and prices. From the top metro areas around the U.S. And it turns out the most expensive average burger was in Santa Clara, California. This was actually really funny because the Strata Data Science Conference was going on in Santa Clara, California right at that moment. And so I got to put out a few obnoxious tweets to friends who were stuck out there eating $23 cheeseburgers, sort of sharing my empathy at that unfortunate state. No cheeseburgers should be $23.
No, but you, as we were saying in the back, restaurant menus, it produces really great and interesting data.
Menus are incredible data, and food is incredible as well. When I was at Bitly, we did a really fun project looking at the words people use to describe their pizza in different parts of the world. And, my favorite is in New York, we call it cheese, it's cheap, and that's about it. It probably has the word raise in it or not raise. In San Francisco, I remember the things that stood out as disproportionately interesting in San Francisco were artichoke, avocado, and stone. And so you can even see from the way people are reading about their pizza, lots of cultural differences can emerge in that kind of data. And I love it also because it's a ridiculous example, but it does show something really interesting.
I love it. And at the end, our new New Yorker, And we are thrilled to have you here, though we would have really loved some Southern California weather this winter, is Professor Deborah Estrin, Professor of Computer Science at the new Cornell Tech campus in New York. She's the co-founder of the nonprofit startup Openm Health, previously faculty at UCLA. Your current focus is on mobile health, mHealth, leveraging the programmability, proximity, and pervasiveness of mobile devices. Your TED Med talk, you mentioned the trail of digital data breadcrumbs. This sort of sounds like bizarrely Hansel and Gretel, but anyway.
And we're continuing our food theme in some way. Yeah, so each time we use our smartphones or mobile apps, social media, even our loyalty cards, we're generating digital breadcrumbs that together form traces of our behavior and activity. And that's by virtue of using services that are digitized, and they do important things with those data, such as knowing how much we've paid for something, helping to connect our calls, giving us our web pages, letting us play our mobile games, letting us watch our Netflix episodes. And those data are used by those services to improve them, to optimize them, to personalize them. But together, all those data that you leave behind about you are what we think of as small data. So I came here and started a small data lab at the new Cornell Tech.
Well, let's go, and here's how this is going to work, is I'm going to ask a bunch of questions. I'm sure it's going to generate questions from people here in the audience. The good folks at Apple, when I get to a certain point, are going to stand around with microphones and jump in. So if you're thinking, do I have anything to ask? Start thinking about things to ask. Let's start with the basics. And I know I've got two people who are going to talk some big data, and then we can count on you, Deborah, to talk small data. But what the heck are we talking about? I mean, I sit with the accelerator and hear startups all the time, telling me they're going to be a big data play. What are we talking about? What the heck is it? What is really going on here?
I'm going to let Hilary start that off, since I think big data is actually kind of bullshit. So,
well, I also
yes, you can swear
we'll
on
start
iTunes.
with what it is before we rip it down.
Okay.
I've never ever liked the term big data at all, because how big does it have to be, right? So some people think big data is data, too big to fit on a piece of paper or in their Excel spreadsheet. There are lots of ways to define it. In an engineering sense, we tend to say big data is data that, because of the volume of it, we require specialized infrastructure to analyze and work with it. So you can't just load it into memory on your laptop or your phone and do something with it. But my personal definition of why big data is interesting is that we have this volume of data, and the volume is irrelevant. What's relevant is that we have the technical ability and the tools to ask questions of that data and do queries and get the results back before we forgot why we asked the question in the first place. So the speed at which we can work with data is improving. So the volume doesn't matter. Some of the most interesting work in data science is done on tiny little data sets. But the tools we have are amazing, and that's why data is interesting. If you insist on calling it big data, that's fine, but don't ask me how many machines I have in my Hadoop cluster, because I don't really care to tell you.
I won't ask. That's the one question I promise not to ask. So why is this all BS?
Well, I think the data that's most interesting to me is actually trapped in unreadable, unaccessible formats for machines. So sometimes I think of myself somewhat as an archaeologist rather than an engineer, because it's all about, okay, we have this spreadsheet that is completely unparsable because someone decided to just put metadata in the first row and then do columns later. How do we build tools that can identify what these problems are and actually parse it so that now it can be accessed through an API? Now you can put it into some sort of analysis and actually work with this data. So I find that big data is an important field of technology, but it's sort of become the entire conversation about data when there's so much out there that needs to be improved and so much infrastructure that needs to be built and supported and developed, and everybody's about how do we get terabytes into this magic box and then have it just produce insight what scares me about that is that for me, it's very similar to what happened with the artificial intelligence community back in the 60s and 70s. They had this idea of like, we're going to build this perfect box and we're going to put everything in the box and then amazing things are going to come out. So I would really like to see what happened there with the fallout of that and not happen in the data community. So I think we need to broaden our scope about what's interesting about data.
So interestingly enough, by the way, they called it, I was alive then, they called it AI winter.
Yes, exactly.
After there had been so much hype about it. So as the person who's least associated with doing work around big data, I want to slightly come to its defense as a term, as well as data science, right? You could just call it statistics, for example.
I actually disagree with that.
Okay. Yes. Good. That's good. But what I think people mean by it is that there's so much data around that was originally captured for a different purpose. So that person didn't put their metadata other places because they were collecting it for some purpose in the small. Service you use is collecting those digital breadcrumbs about you just to run the service. And then it turns out that you can use it to look across a big N number of all the customers of that service, that Amazon, that company that's selling into Amazon, whatever it might be, to begin to look for patterns. When people buy this, do they buy that? Health data. When they have had this kind of exposure, do they tend to develop this disease? When they get this treatment for a disease, do they do better than another one? So that going back and reusing data in the large across large numbers of patients or customers, I think is where a lot of the focus on big data is about, enabled because of all the capability you're talking about. But now argue with me.
Well, no, so maybe then we should call it big questions, not big data, because we're able to ask questions at a much larger scale than we could before, which is particularly fascinating when we think about, social network data or health data. But I will argue with you about data science, in that data science is not just statistics. That's one where I think we do actually need a new term. Data science as a job is several capabilities that have existed for a very long time, but they are only now being combined in one professional. And so that it is statistics and math. The second piece is engineering. It is the ability to write code, to take the models you can build and implement them, to get data out of a database, to clean it, to work with systems like Hadoop or whatever your favorite database happens to be. And then the third piece is knowing what questions to ask. So that is having perhaps the domain knowledge or at least the curiosity to find your way and the ability to communicate the answers to those questions to people in a robust and truthful way, but to people who are not involved with the analysis or the engineering process at all. So it's these three capabilities combined in one job that to me make the role of the data scientist something new. And they're only combined now because we've come so far in terms of the tools, technical process, and the data collection that it's possible for one person not just to learn all these things, but to actually do this job.
Well, I always think of your job, and I know I've said this to you before, sort of like Indiana Jones, excuse me, of the internet in terms of discovering and then what to do with it and the surprise and the serendipity of things you might not have been looking for, the question you weren't asking, and then it appears. But let's go back to, we've talked the big. And for people who haven't watched your TED Med, what are we talking about with small data, Deborah?
Well, as I was saying before, since often big data is about looking across patients, across a population, across your customer base, small data is basically your row or your column of all their matrices, but it's from your cable TV company and your health portal and your shopping transactions. What do you buy at the grocery store? How many of those hamburgers and pieces of pizza do you actually regularly buy? As well as the steps you take, how active you are, what your sleep patterns are, maybe information that you could get from your emails about cognitive fatigue, and that when you wake up in the morning, doing your hard tasks then really makes a difference in how productive you can be. And by looking at that small data, that really in aggregate maybe we can make a future in which in aggregate that's really just accessible to you. You should be able to use that small data, because there'll be cool apps and services that run over it, to help you answer all kinds of questions for yourself. I wouldn't say they're small questions, but they're personal questions. So small data is everything about you that you can get to answer questions for you, in contrast to questions that they ask about us.
So in the aggregate, women between a certain age and our shopping habits, you could look at your own shopping habits against your medical history and your social patterns or all the rest of it and get a really clear picture. I mean,
yes. Does shopping actually make you happier?
Well, I mean, I want to say
Yes.
great personal changes happened in my life last fall, and I can tell you my Fitbit activity was out of control last September. I must have walked the length of Manhattan 16 times a day. But combine that with some other factors, it would have, I mean, if you had put all those things together, it would have been a very interesting and aberration in terms of the portrayal of me if I had had all that small data and would have been able to explain it. So the other thing I want to talk about next is the other word that, besides big data, the other thing that always is out there in this conversation now with this lovely buzzword is real time. What the heck are we talking about with real time?
It depends on who you ask.
I'm asking you, Hilary.
Well, so I worked at Bitly for 4.5 years, and we look at how people behave on the social web. And so real time in human scale is on the order of seconds. That is, when you click a link, you get the page loading in front of you. That's real time. It's happening dynamically in front of you. But if you talk to folks in finance, real time is milliseconds. And if you talk to people who work in like space data, it's on an order of hours or days, right? So there's a rather large variation in how people define real time, depending on what they want to do with it. I'm obviously biased towards the human definition because I'm a human, and most of the data I've looked at in my career is generated by humans and served back to them.
I say that's an important thing to remember with all of this is there is humans behind all the data. We'll talk more on that. Anyway,
I just
Deborah.
wanted to add to that sometimes people use real time in a different way. Not so much that the data is used in real time, but that it's being captured in real time. And so that notion that we're continuously generating data and passively through our mobile phones and our Fitbits and other things is another element of real time. You have a digital trace continuously, even if you're using it at the end of the week, at the end of a month to see whether some supplement is helping you or not. The data was captured in real time. You didn't go back and try to remember it.
So let's go to personal data, because there's mounds and reams and so much of, as Hilary noted, that what's behind the big data are human beings and our activities. How do we get our personal data back? Can we?
Get it back from where?
Or what's the conversation we need to start about collecting our personal data?
I would just re-ask the question slightly, right? When you think about taking something back, you think of it no longer being where it was. And I think that's not necessarily a productive conversation, right? You purchase something at a store, you get your email receipt back to you from the Apple store, right? They keep that transaction record. It's part of doing business. For me, it's can we get access to our personal data? And can we get it in an accessible, programmatically accessible way? I like thinking about personal data APIs, that all the services I sign up for, I should be able to opt in to have that data come back to some personal private place in the cloud where I could run these apps. And starting that conversation that I should be able to get access to my data is really important without scaring people and companies into thinking that somehow means that they will no longer be able to use it.
As a prerequisite to that, we also need to know what data is being collected by these apps and technologies, because at the moment, there's no requirement that people disclose what they're collecting or sharing about you or data that you generated.
And we are generating this data. Do we even have any idea of how much on a daily basis the average person is producing? Sort of like our carbon footprint. What's our data footprint?
I'm sure you can find an infographic on the internet
Can
that
we
will
make
tell
one?
you.
Can we make one? No, that infographic will show, as you and I have talked about, Hilary, the infographic will show things like cats and how many times we've clicked on, the word Kardashian or other things that may depress us.
People love cats and celebrities.
I really like the idea of like pushing corporations to be required to disclose what exactly they're collecting, because I feel like everybody's standard of what you're comfortable with people tracking about you is going to be different, and it's going to be different depending on the company or the website in question. But I think, most of us we're not at all aware of what's being collected about us.
And I've been talking to lots of companies around town and have found a lot of interest, at least in experimentally. We're trying to set up at Cornell Tech a small data test bed with people opting in around the city. And on an experimental basis, from AT&T to Verizon to Time Warner, folks are quite interested. Yahoo, Intel, Microsoft have all these conversations. As long as what you ask for is sort of, can you get back the data that is collected, and you don't ask to get back the data that is inferred. That's the secret sauce. So if you ask just for what is captured, but don't ask them what they infer from that data, because they infer things based on all the other data they have from their other customers.
That also brings up another point where that in many cases, each piece of data or datum uniquely is essentially not that interesting. But if you combine them, you can find out something quite interesting. So you might see that I checked in at Foursquare this morning at my doctor's office. You might know that I didn't go to work today. And maybe you know that I ordered in from Seamless. So each of these alone doesn't tell you anything about me, but when you see those three facts in order, oh, she's sick, right? So there's another conversation to be had as well as, how is the data combined, and, who has access to that?
Right. Which, Deborah, is exactly what you've talked about in terms of, I'm thinking of Ted Madd in that conversation, and the ability to get all those little pieces, all your personal data from all those different sources and what it would tell you.
True, but she's raising a really important point, right? Because one thing is, what data can I get access to so that I can put it to use for me for the questions I have? Another question is, to what extent should I have any control or knowledge of how my data are being sold among data brokers and mashed together with data from lots of other sources of data? And so there's the use on the other side of the data collectors, as well as getting it back to myself.
Right. What would we learn from your personal data today, Marianne?
I have way too much personal data out there. I think an alarming amount of personal data. I agree with you on the Fitbit thing. Like some days I have days where I turn it on and I'm surprised it doesn't say, "Damn girl, calm down." It's just like out of this world.
That'll be the next version, I'm sure.
I see like 60,000 steps today. I think it's really important for people to be aware of what kind of data is out there. I know lots of people who post things to Facebook, for example, and that's a relatively well-known case where you're supposed to realize that that's not a private forum for you to post personal information, but I still know people who do it, and they don't even think about other ways that the data is being collected and analyzed, and maybe they have a problem with that data being collected.
Well, there is this tension between sort of personally putting out that information at the same time it's being put out on forums and platforms and for services that actually improve our lives. And there is this push and pull tension that we can get upset about our data being sold, right? But at the same time, in some ways we've willing and put it out there. And maybe that's part of this whole world now that we're going to resolve that tension, or maybe now that we're aware of it, we can realize, all right, there is something we need to be talking about. Hilary, let's go back to the discipline of data science. How's it evolving?
So data science really didn't exist even 5 years ago, and now there are tons of people hiring for data scientists. There are master's degrees you can get in data science. There are lots of people who identify as data scientists. So it's really feels like it's almost come out of nowhere. At the same time, it's a lot of people applying skills that have been applied for a very long time, but sort of with a new brand and perhaps a new focus. People come to data science from all sorts of backgrounds, usually scientific or technical. but not always. Journalists are doing a great amount of data science, and others as well. So we're at a really exciting point where it seems to be real. I don't think it's going away anytime soon. And we're starting to see the traditional educational infrastructure catch up to it. In the industry, we're actually starting to understand what it is a data scientist does, because as much as I may say you need these three, sets of skills and then you're great, from a day-to-day perspective, the actual work of data scientists vary dramatically from position to position. Some are much more software engineering positions. Some are what used to fall under the headline of business intelligence, more analytics, SQL, DBA kind of stuff. Some are primarily data visualization positions. So we're currently at a point where we have a pretty strong community. We sort of know what we're talking about, and it's pretty exciting. I think we're doing a good job of figuring it out.
I'd like to see more of like a social science background come into the conversation with data science, because one of the things that concerns me is that I see a lot of people who are very enthusiastic about data science, like not understand the inherent subjectivity of data. When you choose to collect something, that's a choice. And for me, the most interesting thing about data is what wasn't collected, what wasn't, what didn't they ask about it? Because that informs the biases that they went into when they decided to collect the data in the first place. Why did they want it? What did they expect to see from it? And so I see a lot of blog posts in the data community where they're talking about data science as if it's the truth and a hard science. And for me, it's really more of a social science. It's about your perspective, your worldview, how you approach this question, how you shaped what you were looking for and what you decided to collect.
That's true. There is a lot of relearning of things that have been known for a long time in other disciplines. And that's actually, I think, a good thing in that people bring very different perspectives to data science. At least on our data science team at Bitly, we had physicists, mathematicians, and economists, a few computer scientists. We'd often yell at each other for 30 minutes before we realized we had learned different labels for the same thing. And so, it does generate what one of my colleagues used to call domestics sometimes. That said, there's also a ton of great work being done under the label of computational social science, which is sort of the academic sister of data science. And I think that is a direction where we will continue to see a lot of growth.
And I would just add that your description of what you'd like to see data science be, really so much of science and engineering and the problems we choose to solve have inherent to it the things we choose to build and the inherent bias, the human element to it. And so hopefully by having that more explicit in data science, it'll spread over to the rest of what we do.
Cool. Very cool. All right. So I think some of this we've answered. I know we were when we were talking back, I'm like, here's what we're going to talk about. A lot of this has come out. So let's look ahead. What should we be leveraging data for? And I'm going to start, Deborah, with you at the end. There's so much of it, what I see being hey, we can collect this data and we can market better too. And then someone picks a demographic. And I'm like, okay, that's great. We have better sales and marketing. But what can we really be doing?
So there are many answers. I'll choose two. One of them is around health. So you mentioned that I have this nonprofit startup called Openm Health, which is all about trying to create an open ecosystem in the area of mobile health, which is how do we use data we get from our mobile phones as well as apps we use to help us do things like manage chronic disease. To be able to tell your doctor when you go in 2 months or 2 weeks after being put on a new dose of your prescription or on a new med or a new combination of med, how are you actually doing? So if it's pain, and there's many issues in this country around the use of pain medications. If your pain is 20% better or 10% better, it's really hard to know that. You're still in pain. But it's really important for the doctor to know that because it means that the course of treatment might actually be getting you on a path to recovery, getting to a place where you're going to be, perhaps largely pain-free or reduced. And so health has been very much inadequately supported with data. Our personal health, as well as even knowing which treatments do better with other treatments. Kurt Cole is the CIO of the medical school at Weill Cornell, and he made a comment, I'll probably paraphrase it poorly, but something to the point of, if you're taking 3 medications, and many, many people in this country are, the older you are, the more likely it is, and more than 3, if you're taking 3 medications, there is no evidence base for the interaction of those 3 medications and your genotype and your phenotype. So there's so much that data can be used for now to help us understand health and to manage our individual health. And the other one, I'll be much shorter, is I don't know how many of you have read books about behavioral economics, whether it's Nudge or Willpower or Senthil Mullainathan's recent book called Scarcity. I think there's a really magical time where behavioral economics meets small data, where the things and the small changes we want to make can actually be supported by data around our actual behavior so that we can close that feedback loop and really be doing biofeedback around many things in our lives.
Those are both awesome. I'm plus oneing that.
Voting
We'll
it up.
retweet it. We'll vote it up, retweet it.
Do
Yeah.
that. No, I mean, I like to say that I think data should give us superpowers. And I mean that in the sense that data and our work with data gives us knowledge about the world that we otherwise would have no way to perceive. So it gives us the ability to know things that without data and technology we could not know. And so I would love to see those things applied to problems that actually do make our lives more interesting and happier. I'm not a huge fan of marketing technology. It's fine, and that's a place where some ideas get tested out, but hopefully those ideas will also help us alleviate the cognitive drudgery that a lot of us spend our time in and solve problems in a way that's very obvious and even boring.
Yes. No, I completely agree. It's like what can be done, which is, I don't know, maybe it's requiring us to think, or maybe just think, but think deeper, think more creatively, think more innovatively in terms of how we can improve our lives so that we're not going back to paper maps and phone books, if anyone remembers what those are.
So I would like to see, this is a bit of a back to the future answer, I guess. I would like to see us do well what we are already pretending we're doing already. And that, I mean that I work a lot with the international community. I work with a lot of people who share data sets via Dropbox and email. And when I talk about version control for data and the importance of data provenance, people are like, what do you mean by that? It's because when you send that spreadsheet out to this person in this agency, they tend to make an assumption and decide to tweak it just a little bit, and then they send it to somebody else in some other agency, and they tweak it a little bit, and they tweak. And these individual tweaks are not necessarily unscientific. A lot of times it's a really natural assumption of like, okay, this is the population of this sample size. Let me sort of like ratio it out so I can have an estimate for this entire country. But when you don't realize that the data that you're using has been passed along this kind of like telephone line from person to person to person, then all of a sudden the UN or the World Bank comes out with this completely ridiculous, totally incorrect line, like half of the people in Sweden are actually mutant lizards, and it's just an absolute, it doesn't become data anymore. So
Right.
What we talk about is this idea of like, it's really important to have some sort of documentation of what has been changed with this data by the time you get it, so that yeah, I can't really tweak it anymore. It's already been tweaked enough.
What principles should be applied to data?
It's interesting because I think that it's important for data to be structured in a way that makes it easy to restructure it when you need to. But you ask 7 people what that means, you'll get like 8 different answers. I tend to avoid conversations about standards and metadata. Actually, they make me want to rip my hair out and run around screaming.
Let's not do that. Please don't, when we go to questions, please don't ask that question. It would make for an exciting podcast, but let's not ask that.
Not because it's a bad topic, not because we don't need standards, and not because metadata is not bad, but because I find that it's usually a discussion that's used to actually derail the conversation from actually accomplishing anything. Everybody agrees we need standards, but then everybody's like, yes, everyone needs to use my standard. And then when you talk to them about like, no, let's come up with a uniform standard that everyone agrees on, and this is not unique to data, it's just the nature of standards. But for a lot of people who have problems with data, the first conversation they have is about standards and metadata, and that to me is like the last conversation to have. It's about how do we put the data in a format that if my needs are different from your needs, you can like manipulate the data in a safe way so that you fulfill your needs and I fulfill my needs.
Cool. Deborah, thoughts on principles that should be applied to data?
I think the one that's most top of mind for me is what I've said before, which is that we need to create a future in which we have programmatic access to our data, that we have personal data APIs. That by no means is the only one, but most important to me.
There we go. Yes, we have questions. Fantastic. Thank you.
Thank you. Good evening. I was wondering if you ladies are familiar with out of sight, out of mind, where a company basically took the data about the U.S. drone strikes in Pakistan and did a data visual map to show the devastation and how many people were actually affected by that. So I was wondering, what's your thought or opinion on companies doing that nowadays to actually use data for social causes, and how accurate is that data that they get?
Well, I love it. And I think that's a wonderful use of data. It is helping us learn more about the reality of what is happening in the world, and if there is a reason that we might want to be socially aware of it, we can be, and we can take action on it, and on a fact basis. As far as how accurate that data is, unfortunately, I have no idea.
I mean, I want to just go to what you were doing at Bitly in terms of pulling data now. You were pulling it from social sites, and I'm going to say some ways human behavior and social graphs. Is that the kind of place where you can, from our posts on Facebook and our tweets and the links that we click, can you get some of this kind of, I want to say, activity that someone actually may not want to know, that we're cutting down a piece of the rainforest or whatever we're doing?
Absolutely. You can learn quite a lot from people's behavior on public social networks. But as a word of caution, while I was the chief scientist at Bitly, I read every research paper I could find where somebody used Bitly data in the paper. And I never found a paper that was written by a researcher who didn't reach out to us that made correct assumptions about the data they were looking at. People who did reach out to us, we did our very best to assist with their work. We gave them data sets. We had a policy about it that I think was pretty great. So I have also a lot of skepticism when I see work where people are scraping data that they don't know how it was generated, they don't know how it's stored, they're doing an analysis, they're coming to a conclusion. I personally have a lot of skepticism about the results.
So this is, oh, sorry.
Go ahead.
Yeah,
Go ahead, Deborah.
I also love data being used for social causes. And I thought it was really interesting you brought up the rainforest, because I met an entrepreneur a couple days ago who was telling me about a project that he did with mobile phones and Indians in the Amazon, indigenous people in the Amazon, and how they make money off of carbon credits, basically. But they also had to deal with illegal logging. So they basically built an app where they took a picture of the rainforest as they were moving through it, and it recorded the place, the time, and the direction along with the picture. And then when there was illegal logging, they would come back and they would take another picture. And then from this information, they were able to track, okay, which company was operating in this area. This is the company that was doing the illegal logging. And since the groups that are doing this are making money from these carbon tax credits, they're taxable by the government of Brazil. And so now Brazil is interesting, because if there's less tax credit money coming in, then there's less taxes, and now they're enforcing illegal logging and cracking down on these companies. And it's all because of the data that's being collected.
So just a really important question, and I think a very important segment as a result of this conversation. It's really complicated because we want data to help make visible and present what wasn't before, and yet it made me think of a principle. You asked before, what's the principle of that data? Particularly in this kind of context, you'd like to be able that data to be verifiable. And you'd like to be able to get pointed back to where the source of the analysis is, so that there can be an open discussion about how it's being interpreted. And while I hope we're increasingly interested and increasingly looking towards telling stories with data, I hope we're also increasingly educated about recognizing how many different stories data can tell.
It's not perfect. The data's not perfect. Damn. All right. We've got a question there. Okay.
PBS had a documentary called Dropout Nation, in which social scientists went up to South Bronx and they started collecting a lot of data on student behavioral patterns and their performance. I know one interesting correlation they made was that students who struggle with reading in the 5th or 6th grade have like a 60% higher dropout rate than their classmates in any other subject, and they're wondering why was it English as opposed to like math or science, something like that. And so I'm wondering, we talked about people giving away their information. We know that statistics like that are very helpful in monitoring students who are now posing dropout rate risk in the 6th grade, not in sophomore year. But what are your thoughts on us measuring the behavior and collecting behavioral data on minors who can't necessarily give their consent to give it away?
Well, aside from the issue that it's a minor, there's the other side to that, is if you are kind of measuring who's most likely to drop out and who's most likely not to, at one point does that become a self-fulfilling prophecy? At what point do the teachers and the administrators and the parents and even the students themselves kind of go, yeah, okay, maybe work on your basketball game or something like that? I think that would be, to me, the most pressing concern, because you often see people kind of confuse a correlation with destiny. And just because there is a correlation between this point and that point does not make it destiny.
I just was talking to somebody yesterday who had done work on being able to build a better model with the city's data to predict homelessness for families. It's a similar social example. It's at the unit of families. It's data that the city already had, but if you can intervene earlier and prevent homelessness, right, you've done an incredible thing for the family. So I think if we can turn this around, schools already are collecting data. It's part of how they run. And if you can work with schools to predict better models, the problem is you need to have some action you can take that's going to help and that's going to be meaningful intervention. And so I wouldn't overly focus on the data as much as focusing on what's that intervention that can make the difference.
Yeah, even if we had better data and a better predictor, if there's nothing useful at the end other than saying, look, we have a white paper, if we have some resources, something to keep the kids in school or prevent homelessness, but other than saying we have a great predictor, what's the point?
So I want to get back to a topic that you were talking about just before we started the questions, and you were talking about metadata and the organization of data, and that's an interesting area for me. So organizing data so that it's semantically meaningful. Talk to me a little bit about data ontologies and who's sort of leading the charge in that area, and what do you guys know? Who do you know that's doing work that's interesting, et cetera?
Oh, this is the part where I tear my hair out and scream.
Yes, we have excitement.
Like ontologies and any kind of like classification system is a tricky subject, because you are never going to build the perfect classification system that covers everything. I don't know. I was talking to somebody a week or two ago that was talking about the perfectly to scale map is the world. If you want like something that is an absolute perfect representation of everything in the world, you basically have the world, which is not useful. So I honestly don't know who the leaders are in
Don't look at me.
Classification.
I'm just the moderator.
It depends on the field. So I'm smiling because my co-founder of Openm Health is Dr. Ida Sim, a real doctor. She's an MD. And her specialization at UCSF is on ontologies. And many people find it a pretty trying, sometimes they use other words like tedious topic. But in the end, if you want to compare your blood glucose measures over time or your blood pressure over time or different things, how that data is represented better be done in a way that means the same thing. And as we start to bring in patient-generated data, if you're an older person who's going through treatment, they're trying to see if you're up for surgery, turns out one of the standard tests they use is called the get up and go test. What is that? How long does it take you to get up and go? Functional measure. It's brilliant because it requires integrating all kinds of muscular, neural, cognitive things. And if you're going to measure that, and once it's in the emergency, how do you represent that? What do you call it? It's really important. And the more we do large data analyses or small data analyses, we have to get the ontologies right. So thank God for smart, careful people, and it's by discipline that you find where they are. A lot of people, and Amy and him's doing it in the medical field. And you have to go not to the stat or the computer scientists for the most part. You need to go to the domain experts who do the right ontologies for that domain.
There we go. How are we doing for time? We got time for another question? Perfect.
I wanted to ask, in keeping with the semantics, I wanted to ask, sorry about that, what kind of mathematical models are typically used that have you guys seen? You can keep it to like natural language processing, for example. I know that's a big area. They usually use Markov chains, weighted neural nets, or combinations.
The right approach for the problem.
There we go. Big question, succinct answer.
The days of people sort of fighting over those, I think, is in the past, and hybrid techniques, and depending what the data are like.
Thank you.
Hi. First of all, thank you. This is a really insightful talk. I appreciate that. So I want to talk about inference and assumptions, right? Because everyone's saying, oh, data by itself, blah, 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 what are you going to do? You put things together, suddenly you have these interesting models. But there's assumptions that are involved in that. And to points that were brought up earlier, there's stuff that was not captured. So what kinds of guidelines or what kinds of suggestions or what kinds of feedback do you have for folks who are assembling things to say, watch out for and be aware of as you're building those models so folks can see, here's the assumptions or here's blind spots? And I realize that's a big question, but I'd love to hear your feedback. Thank you.
As a programmer, we always say document your code, document your process. I don't know why more data sets don't come with a README file that says sort of, this is why we collected this data, this is how we collected it, this is the sample of people that we used, and how we got the data in the first place. And when I suggested this at the UN, they were like, what are you talking about? Why would we put a README file in there? It was because it's useful, rather than putting your metadata in the actual data where someone might actually have to remove it because it would make it difficult to parse, put it in a README file so that people can have that information.
It's like a footnote. You need those things.
I mean, I'd say some of that comes from expertise and practice, but whenever we did a data analysis problem at Bitly, we had a very simple set of questions that had to be asked and answered before that project would proceed. And those questions were first, define the thing you are trying to understand clearly. And that means in language that anyone can understand. Not in, obfuscated mathematical language. And sometimes that's harder than you think it should be. The second question is, how do we know when we've won? So what are our error metrics for our answer to this question? And what do we need to be aware of in terms of validating that what we've done is correct? And then the other questions were more on the product business side. So I'll mention them quickly if they're interesting, but it's, assuming we can solve this perfectly, what's the first thing we'll do with it? And then finally, assuming we've done that thing, how does it change human behavior? Are we working on something that's of high impact, or is it an incremental improvement to something we already understand? And then I also like to ask, what's the most evil thing that can be done with this? Mainly because I work with people who are very lawful good. They are extremely well behaved, and it's nice to get everyone thinking very creatively about potential applications of what they're working on. But those first two questions really are making sure that as a team, we agree on what we are doing and how we will understand it in the context in which that problem lives.
I would say, for me personally, I generally, if I can't decide whether or not I should collect it, like whether or not I'll need it, I'll collect it. Because you can't go back later and collect data you haven't collected. But if you don't need it, you can just disregard it.
Any thoughts?
Perfect question. Perfect answer.
Perfect
It's
answer.
just there is no perfect answer. It's a really hard question.
Good, because the last two questions I felt like I was sort of rambling, and then Deborah just came and nailed it, and I was like, no, that was exactly right.
Darn, Professor, that unreal doctor at the end, as opposed to those real
I
doctors.
felt like the warm-up act. It was amazing.
Got time for one more?
I like the point earlier that you can make a lot of points with data depending on how, numbers are just numbers, and it can be spun a lot of different ways, and that can be dangerous too, right? If you omit certain variables and report certain. So what do you think, how much more advocacy can be done with regards to people who collect the data, kind of remind people this is just numbers, and there's a story. The methodology was critical, response bias was critical, especially if it wasn't automatic.
I mean, yes, that's really important. I taught a class at NYU last year, and one of the things we tried to do was to pick a graph out of a newspaper article or newspaper news article, and that was created with data that was accessible, and try and recreate it to try and understand what bias went into creating that piece, to even see if we got the same results, and in some cases we didn't. So yeah, there's a lot that you need to be aware of when you're consuming these stories. Even just asking yourself really simple things like, what were the decisions that were made about the axes on this graph? Is the graph labeled? Are there any sort of error metric visible? Are there error bars, p-values, whatever? And then figuring out how the text ties into that. And if you're someone who is writing a story, you are the one making those decisions, and you have the responsibility to do it in a way that is truthful to what's in the data, but still interesting because you owe your audience that. And also, generally you are trying to make a point. And so that's why we need professional journalists.
I think this is a really amazing way to start the conversation with the general public, because it's not necessarily a conversation that you need to have a very strong technical or scientific background in order to participate in. So for example, there's an infographic I saw on Mashable a year or two ago that was comparing the percentage of farms in the United States to the percentage of people who play Farm Bill. And I was like, seriously, that's like fourth grade math, isn't it? That you can't compare percentages of different things and draw a conclusion, but that's exactly what they were doing. So the popularity of infographics is very useful in having this conversation with the general public and getting them to be more aware of how data is used and how data is manipulated, because you don't have to have an advanced degree in statistics or computer science to understand why 75% of a hot dog is not necessarily more than 40% of a pizza. Sort of.
I'm getting really hungry.
And we're back to food.
And before we all leave for dinner, that brings up that what we need is teaching more about data and data science and computational thinking across the board earlier in schools, in schools, and that our NGOs and not-for-profits and advocacy and our journalists know a lot about data, so that when an article is published, there can be a conversation about the data and the assumptions and the biases underneath it. And it's great to see what's going on in this great city that I'm now delighted to be a resident of, from Cornell Tech. We're training data scientists who go off to nonprofits and social entrepreneurship as well as commercial. My close colleague Mark Hansen is teaching data journalism and computational journalism up at Columbia, and you have the Cusp Center at NYU. There's really a lot of attention of bringing those skills of data to all elements of the economy.
Very cool. Before I let my good friends here wrap this up, is there anything we didn't talk about that we should have talked about? And if people have additional questions, where can they find you? And where's the best place to find you? As I always say to people, find me on Twitter, at JK Hoey. That's where you can find me. That's the best place to find me. So.
Basically, every contact form on Exversion will somehow lead to my email. So you can also find me on Twitter as Bellmar, Bellmar. Yeah.
The only other thing I would mention is that we have a conference called Data Gotham in September. So if you love data, you should come. It's people talking about their practice with data from a bunch of different industries and backgrounds. And all the videos from the previous 2 years are online. So check that out. And if you want to talk to me, I'm H. Mason on Twitter, or my email address is me@hilarymason.com. And I'm very easy to find, and I answer my email.
She does, I can tell you that. And the conference in September, it's here in New York City?
It'll be here in New York City.
Awesome.
And Deborah.Estrin@gmail.com. That and many other email addresses get to me, and I read them all, and I try to answer them most. And anyone interested in both mobile health and small data, that's what we're doing these days at Cornell Tech.
Fabulous. Thank you all very much.